These are the frequently asked questions in Algebra 2 for section 2.6 day 1. The first one that generally people ask for is number 37 here. And in number 37, it says write the equations for f of x and g of x, then identify the reflection that transforms the graph of f of x to the graph of g of x. Basically telling us that f of x is the pre-image, if you remember that language from last year in geometry. It's the before, and then g of x is the after. So for f of x, what I want to do, because it appears to just be something easy I can do with slope-intercept form, is just figure out, all right, well there's my b value right there, -1, and to go from this grid point to this grid point, I just need to count 1 down and 3 over. So my slope is going to be rise over run, -1, 3. Remember it was going down, so that's going to be a negative. X minus 1. So there's f of x. And then I look at g of x, and I realize g of x has to be a reflection over the x-axis. I mean, pretty obviously it's flipping it over that. So I could cheat a little, but I know they don't want me to do that at this point. So what I'm going to do is just go back and do the same thing, looking at g of x and realizing that this time I have my b value right there, which is a positive 1, and I will need to go up 1 and to the right 3. So positive 1/3 x plus 1. So write the equations for f of x and g of x. Identify the reflection that transforms the graph of f of x to the graph of g of x. And remember, as I had said, it's a reflection in the x-axis. Now I can verify that by starting with my f of x equals -1/3 x minus 1 and just putting a y in. Remember, if you have trouble with that whole notational thing, it's easier to just see it as y. And I said it was going to reflect over the x-axis, and to reflect over the x-axis we would make a -y to make that reflection. And now, of course, if I want y all by itself, I would need to divide everything by a -1. And ta-da, there we get g of x. So we always have to make sure that what we're doing makes sense. And in this case, definitely, all of that makes sense. Now, on this transparency, or slide here, I should say, I thought maybe 52, I don't know. Like I said, maybe not any at all. Maybe you were looking at this and saying, all of this is good. But here's what we had, y equals 2x minus 1. And 52 says we're going to move that 3/5 units up. And what we found out was that when you do that, what you're really doing is you're just adding 3/5 to that constant that's in the back. So we would have y equals 2x, and then we need to think of that little one as 5/5 there. And so that will be a -5/5, and we will have -5/5 plus 3/5, which will give us a -2/5. And then, of course, you look up and this one's multiple choice, so it just makes sense that it's F right there. And again, that's that K value that's responsible for up and down, so our constant there is really that K value in the back, doing its little up and down thing. And then I thought maybe I ought to remind everybody on number 56 that we have our little jail bars there. This is the prison break, but it has to be isolated. So we have to go ahead and subtract 2 from both sides before we can get our 2 escape routes. And now that we have that, we want the 2 escape routes, so x minus 3 will equal a -5, and x minus 3 will equal a +5. We'd add 3 like crazy all over the place here. And then, yeah, we should quick check and make sure this is going to work. So if I put a -2 back up in there, I'll get -2 minus 3 is -5. The absolute value of that is 5, and 5 plus 2 is 7. And likewise, I'm going to take my lovely little x equals 8 and put that in there. So 8 minus 3 is 5. The absolute value of 5 is 5, and 5 plus 2 is 7. So don't forget that for these last three problems. You have to isolate that absolute value first before you do your two escape routes, your positive and your negative. That should be it.